Physics students, good afternoon. Mr. Fugit here. In this video today, we're going to be looking at a problem involving circuits. Specifically, we're going to be looking at the relationship of current, voltage, and resistance within a circuit. In this video, we're going to be looking at problem number 22, which is the last problem on homework assignment 14. The problem reads like this. A lamp dimmer is puts a resistance in series with a bulb. What resistance would be needed to reduce the current to 0.55 amps? So it's important for us to understand what 20 and 21 are asking before we get to 22, so we're quickly going to solve those first. You're given a circuit diagram in question 20. Looks a little bit like this. We have a battery, and within that battery is attached to a circuit, and within that circuit there's one light bulb, and we'll treat it just like it's a resistor. Now we're told that the bulb has a power of 78.5 watts, and is connected to a 110 volt source. So probably plugged into some type of wall outlet or wall socket. And question number 1 is asking us to solve for the current going through our circuit. And here we can use our power equation, PIV. Remember, it's powerful to be able to check your grades. So PIV, I can use this to get current by itself. Current I is equal to, well, divide the V over, so power over the voltage. So I'll take our power, 78.5 watts, and divide by our voltage, 110 volts. Now when we do that, 78.5 over 110, we get a current of about 0.713 amps. Now, if the question asked us to solve for that in milliamps, we would simply multiply by 1,000. So we could say it's also 713 milliamps. But the question is actually asking for that current in amps. So we can simply use our power equation to solve. That's 21. Now 22 is asking us for the resistance of the bulb. And that's very important for how we're going to solve 22 eventually. So 21 asks us, what is the resistance? Now we have current. We solve for that in 20. We know the power, we know the voltage, and we want to find the resistance. So, usually to relate some of those characteristics of a circuit, we can use Ohm's law. So 21, we're simply going to use Ohm's law directly. Resistance, R, is equal to voltage over our current. And we can now use Ohm's law because we've already solved for the current. So our voltage, 110 volts, divided by the answer we solved for in problem 20, 0.713 amps. So we'll plug that in momentarily. 110 over 0.713. And when we do, we get a resistance value, R, about 154 ohms. Check and see if that's correct. Boom, we got it, 154 ohms. So again, questions 20 and 21 are very basic application of our power equation and then using Ohm's law. Now the last thing it's going to ask us to do is this. And the question says in 22, we're putting a dimmer in series with our bulb. So say we're going to add something in, like right here. Something along these lines. We're basically going to put another resistor in series. Now we know that to find the overall total resistance of our circuit, we can simply add those together. But that's not really what the question is asking us to do. The question is asking us what resistance we need here in order to drop our current down to a certain rate. So here's what we're going to do. We're going to use Ohm's law to start, question 22. We know that we want our current to be 0.55 amps. We know that our voltage, and what we're getting from our wall outlet or battery or whatever it is powering our circuit, is 110 volts. What we don't know, according to Ohm's law, is resistance. Now when we use Ohm's law with these variables, that resistance it's going to give us is the overall or total resistance. And then we'll talk about how to back solve for the resistance of our dimmer. So let's use Ohm's law. Resistance, R, is equal to voltage over the current. So voltage, 110 volts, divided by our current that we're now dropping down to 0.55 amps. Don't use the current you solved for previously, use the new current. So 110 divided by 0.55. That's going to give us a resistance, wrong side of the marker, of 200 ohms. Now remember, that 200 ohms is accounting for the bulb itself as well as the dimmer that we just put in series. So we know that our total, or what we would call our equivalent resistance, is 200. So we can say our equivalent resistance is equal to 200 ohms, which is equal to the resistance of the dimmer plus the resistance of the bulb. Okay? Remember, we're looking for the resistance of the bulb, not the total, excuse me, we're looking for the resistance of the dimmer. Not the total, not the bulb, just the dimmer. So we'll plug in what we know. 200 ohms is what we have total, is equal to the resistance of the dimmer, what we don't know, plus the resistance we found of the bulb in the previous question, 154 ohms. And as you can probably tell by now, we simply need to subtract the resistance of our bulb over to the other side of our equation, and we'll get a resistance value for our dimmer that is equal to 46 ohms. So we'll check our answer key. We got about 45.9. We solved for 46. I did a little bit of rounding here. But for the most part, that's going to give us the answer that we're looking for. So here, it's a matter of understanding equivalent resistance is the sum of two resistors that are in series, and how to use our power equation and Ohm's law. Hopefully this will get you started on solving questions 20 through 22. Good luck.